Before I explain the purpose of incidents and how they're generated, it would be worth comparing the concept of an incident with that of an event. Whereas events are raised to notify a user that something has happened, incidents are raised in response to one or more events to indicate that there's a situation that needs attention. It's also worth noting that not all events result in incidents being raised. An important goal of the event system is to reduce the number of separate incidents presented to operators while increasing the value and relevance of each one. I'm going to use some of the standard provided incident definitions to illustrate this concept. When I select the Events option on the main menu bar, a list of open incidents is displayed. If you look closely at the header of the table, you can see that it's labeled Incidents. Let's take this port status problem. It's warning the user that a port on a device is in the operationally down state. Even though the system may have detected this from either an incoming trap or a regular polling operation, or both, there's only one incident describing the current situation. Let's wait a moment and see if anything changes. You'll notice that the message has now been updated and that the incident is reporting that the port is now in a flapping state. That's warning that it is regularly oscillating between the operationally up and down states. The individual state transitions are no longer causing an incident to be opened and closed, and this incident, warning of the flapping situation, will continue to be open until the port settles in either the up or the down state. If it stops in the down state, then the incident will be updated to show the down state, but the incident will be closed and removed from the list if the port settles in the up state. That port has now settled in the down state. It's no longer flapping up and down, and I can explore the history of events that contributed to its state changes using the Show Details option. Here's the most recent event at the top of the list, which was a trap-derived link down event. Here's the port flapping event, which was internally derived within the events system as a result of seeing several port up and down events over a short duration. Those port up and down events were themselves discarded and replaced by this single port flapping event. Here was a port up trap event that had caused it to be seen in the up state previously. All these different events have been gathered together and represented as a single incident. Other incidents, such as this one warning of a device reboot, may also warn of a sequence of related but different events, and these can be seen if the details are displayed. This is an example of an incident which doesn't have an explicit closing event, so it's automatically closed after a time defined in its ageout setting. The ageout is an optional setting, and many incidents don't have an ageout setting. An incident is considered to be open until its ageout time expires if it has this setting, another event explicitly closes it, or an operator manually closes it. There is then a period of time referred to as the expiry period, during which the same incident will be reopened if an opening event is received. Once the expiry period has been exceeded, any new opening events will open a new incident instead, but details of the original incident are maintained in the database for a further 7 days, so it can be viewed when investigating the history of a problem. This is how an operator can manually close an incident without waiting for it to be closed automatically. If the checkbox is left unchecked, the incident is simply closed, but can be reopened if a further opening event is received. If, however, the checkbox is checked, then the incident will be considered to have expired and cannot be reopened, but as I just mentioned, it will be maintained in the database for a further 7 days so that you can view it on request. An incident can also be assigned to another user in a similar way to many trouble ticketing systems. By assigning an incident, the owner is included in its details. But everyone else who has permission to see the incident can still see that it is still open. The history of events can also be displayed by switching this viewer into the event mode. The raw events can also be forwarded to external event handling systems, such as BMC Proactive Net Performance Management. The list of incidents and events displayed in the viewer can be controlled in several ways. If a view is selected in the navigation tree, then only those incidents relating to components within that view are displayed in the incident viewer. In a similar manner, selecting a device or port in the navigation tree causes the list of incidents to be further filtered to only those originating from that component. The events generated for each view are controlled by an event filter, and various different event filters can be created and assigned to different views. If an event doesn't pass the event filter, then it will not be forwarded to an external event handler, where the handler is configured to listen for events from that view. Regardless of which part of the navigation tree is selected, a further filter option is also available. A collection of viewing filters can be created by a user to control which types of incident or event are displayed. These filters are associated with that user's account and cannot be deleted or altered by other users. These filters only control which incidents and events appear in the viewer and have no impact on the forwarding of events to external event handlers.